Welcome back to video number 8 of the series on Basic SQL, an introduction to the structured query language used by most relational databases. In the last video, we were introduced to the select statement and its three primary clauses: select, from, and where. In this video, we're going to continue that study of the select statement. So let's get started. On occasion, one will find that different tables use the same names for attributes. For example, ID would be a common attribute name, and you might find that in any number of different relations or tables. Name or city, state, zip, those are all very common attribute names that one will find in a variety of tables or relations. The problem comes when you're trying to query data from multiple tables that have attributes with the same name in them. It creates an ambiguity that SQL has difficulties with. When you say you want to see the name, address, city, and state for all the employees in the research table, when both the employee table and the department table have attributes called name, then SQL doesn't know which one you're asking for in the select statement. Here's an example. We got select fname, comma, employee.name. There you see it's qualifying which name attribute it really wants to retrieve, and then comma address. And this is being retrieved from the employee table and the department table. And the where statement says where department.name, there you go, qualifying an attribute called name because it's in the department table this time. Where department.name is equal to research and department.dnumber is equal to employee.dnumber. In this particular instance, there is an attribute called dnumber in both tables. So it's very easy to solve the problem of duplicate attribute names in multiple tables simply by qualifying them with the relation name or the table name. It's also possible to create an alias for a table when structuring your SQL query, and that is declared with a statement like this one: employee as E. In other words, the programmer is using a variable or an alias called E to represent the employee table. We mentioned that the three clauses of the select statement were the select, from, and where clauses. It is possible to write a statement without the where clause, but when you leave out the where clause, you're really limiting the usefulness of the retrieval. Here's a couple examples right here. Select SSN from employee. All right, well, that's great. That's a legal statement. It would retrieve all the SSNs from a table called employee. I'm not sure what use a query would be that just gives you a list of social security numbers without any other related information. Another one down here below says select SSN and department name or DName from employee, comma, department. Well, that query right there presents a series of problems. First of all, since you're not tying the two tables together in a specific manner to retrieve specific data, it will essentially give you every possible combination of data from those two tables, which normally is meaningless. Let's take a look at some examples of the things we've been talking about. We have a couple of tables here that we can work with. Let's select everything. We're going to talk about this asterisk wildcard shortly. From customer, and end that with a semicolon and execute it, and we see that we have selected all the attributes in this customer table. And we have a customer ID, a store ID, first name, last name, email, address ID. All right, so we see a number of pieces of information in that table. Let's look at another table. Let's switch this one to the address table. and execute that, and we see a number of addresses. We've got a city ID, so that would suggest to me that we have another table with cities in it. But we have an address right here, 28 MySQL Boulevard. That's interesting. That's the address ID. And what we have noticed is that both the customer table and the address table have attributes called address underscore ID. And we should probably be able to conclude from that that they are linked by that common piece of information. The customer is linked to the address by the address ID, where in the customer table, address ID would be the foreign key, and in the address table, address ID would be the primary key. And so therefore, if we want to query and pull up a list of customers and their addresses, we should be able to do that query and join the two tables together to get the customer's first name and last name out of the first table and their street address out of the second table. Why don't we try that? Select first name, last name, and address. Now, first name is located in the customer table, last name is located in the customer table, address is located in the address table. Now we have to tell it which tables to pull this information from, and that would be from customer and address. Okay. In the previous slide, we saw that we could input data without a where statement. Why don't we see what that does? We'll put a semicolon right there and execute. And that gives us a whole bunch of individuals, it appears, with the same address. Notice what we're getting here. A lot of different individuals have exactly the same address. Now we're using a workbench application here to write this query. It looks like from this query that all these people live at my Sakila Drive. Let's try this query from the command line instead of the workbench. First of all, we need to tell it to use the name of the database, which in this case is Sakila. And now we can input our statement. Select first name, last name, address from customer, comma, address, semicolon, and now it will execute. And look at it go. It's going, and it's going, and it's going, and it's going. Essentially, without that where statement, it is pulling up every possible combination of data. In other words, it's pulling up each customer, giving each customer the first address, the next customer the first address, the next customer the first address, then it goes through all these records. I'm going to abort this thing, and it aborted at 361,197 records. That's not going to be particularly useful. So leaving the where statement off is not a good idea. Let's go back to our workbench and try this command again, but this time let's add the address ID to the list of attributes that we want to retrieve. Because of the fact that address ID exists in both the customer table and the address table, we need to qualify by using one of those table names, and we will use customer.addressID. This way, SQL won't become confused about exactly which address ID we want to see. In this particular instance, it really doesn't make any difference. It's the same number. But if we were joining together two tables that had, for example, a name attribute, well, there would be two different pieces of information, probably. Okay, now that we've got we've added the address ID to our list of attributes to query, we need to come down here to the bottom and add our where clause. Customer dot address ID equals address dot address ID. We'll end that with a semicolon, and execute that. So we get a list of records, first name, last name, address, and the address ID. And notice, because we joined the two tables together properly, it has given us the right address for the right customer. No duplicates, the right address for the right customer. Let's go back and take a look at that query again. Select first name, last name, address, customer dot address ID. We talked about aliases. Let's put in here C dot address ID, and where it says from customer, let's say as C. We'll add that to it. While we're doing it, why don't we just give address an alias as well? So we're saying select first name, comma, last name, comma, address, comma, C dot address ID, from customer as C and address as C, where C address ID equals A address ID. These are just aliases that we're using, and once you become proficient, it can save you some typing. And it can also be used in other examples that we'll explore later. Let's see what this does. Ran just fine, didn't it? Gives us that same list, same query, same everything, except we have used an alias. Why don't we use alias for our mystery word this time? We have used an alias here instead of the name, and we define the alias right here in the from statement. Customer as C, address as A, and we said first name, last name, address, C address ID, where C dot address ID is equal to A dot address ID, using the aliases. Well, that was a lot of material. So I think we need to stop here. And why don't you go ahead and submit your mystery word, and then go out and check your knowledge on what we've covered in this lesson, and come back for lesson number 9.